Hello students, we'll continue with motion in two dimension in this video also. In fact, this is the last part. We have seen oblique projectile, we have seen equation of trajectory, we have seen horizontal projectile, projectile from a height, and the final topic in this is relative motion. So what is relative motion? First, let's try to understand in this one-dimensional motion. So when the object is moving in a single dimension, let's look at this example. You can see there is a person who is moving inside a train at 2 meters per second and the train is moving at 9 meters per second. So what would be the speed of the train as seen by the person? It would be 9 meters per second. And what would be the speed of the person inside the train as seen by a person from outside? So it will be 9 meters per second, the speed of the train plus the speed of the person, because person is also traveling in same direction. So the answer would be 11 meters per second. Now let me make a small change to this. Instead of moving forward at 2 meters per second, let's say the man is moving backward at 3 meters per second, right? In that case, what will be speed? So velocity of, I will try to represent it as velocity of train with respect to ground is how much? It is 9 meters per second. Velocity of person with respect to train in the new case would be how much? Minus 3 meters per second. Then velocity of person in the train with respect to a person on the ground is equal to how much? Velocity of train with respect to ground plus velocity of person with respect to train. So that would give me 9 minus 3, that is equal to 6 meters per second. In fact, if the person starts running backwards at 9 meters per second, for a person on ground, he will appear to be at rest, right? So the idea about this example is the velocities that we see might not be same for everyone. So the velocity of train as seen by a person outside is different, or so velocity of a person inside the train as seen by another passenger would be different than as seen by a person from outside. So it means that velocity depends on the position from where we are viewing it. So that's why we define this term relative velocity. So relative velocity is what? It is velocity of an object with respect to a reference frame. So because with respect to different reference frames, what will happen? Velocity would be different. So if I want to coin a formula for this, I can say I represent this VAB. This means velocity of A with respect to B. So velocity of A with respect to B. Velocity of A with respect to B is given by VAG. So velocity of A with respect to ground minus velocity of B with respect to ground. Now this need not be always done, but the condition is both of them should be with respect to the same frame. Then only I can find relative velocity of one object with respect to other. I can't say that there is a person walking on moon and what would be velocity of this person as seen by a person on earth, because there are other motion of moon coming into picture, rotation of earth coming into picture. So in that case I can't use this formula. Under what case I can use this formula? This formula can be used only when both the persons are walking on ground, or both the persons are walking on train, or both the persons are traveling on two different ships on this in the same sea. Of course it doesn't make a difference because we assume sea water is at rest, so any sea. So this is what is the expression for relative velocity. Relative velocity of A with respect to B is velocity of A minus velocity of B when A and B are with respect to same reference. Now let's extend the same idea into two dimensions. So here you can see there are two planes, plane A and plane B. Now I want to see velocity of, this is velocity of plane A, this is velocity of plane A, and this is velocity of plane B. So I can use the same formula. Velocity of plane A with respect to B is equal to velocity of A minus velocity of B. I can use the same formula. There is absolutely no problem with that. So in that case, what will happen? Velocity of A with respect to B would be VA minus VB. So here we'll try to draw this. VA, we know this is VA, this is VB. Then minus VB will be just opposite to that. Now this part becomes, this is minus VB. So this will become, by triangular law of addition of vectors, this is VA minus VB, which is relative velocity. So I can apply the same formula to, same formula of difference of vectors, that is difference of velocities of the two objects, to two dimension or three dimension also. Now let's look at the common examples that we often study, that is relative motion of rain with respect to man. Now let's assume that rain is falling vertically. If rain falls vertically and man starts moving, then he will feel that rain is striking him at a certain angle. So let's say in this particular case, what is it? This is velocity of rain with respect to ground, and this is velocity of man with respect to ground. So because man is moving, he will feel that velocity, this is how velocity of rain will strike the man. What does my formula say? Velocity of rain with respect to man equal to velocity of rain with respect to ground minus velocity of man with respect to ground. This is what is the formula. So I use the same triangular law of addition here. So this is velocity of rain with respect to ground. Now this is velocity of man with respect to ground. This will be minus velocity of man with respect to ground. This is minus velocity of man with respect to ground. Now I complete the triangle. This is how we get it. So in this way I can find out. Now once you know, for example, let's say man is moving at 4 meter per second. Now what is the velocity at which rain appears to fall if it is falling at 30 degrees? Then I can use trigonometry. By trigonometry I can use sine 30 equal to 4 by velocity of now. So if I look at this triangle, I can write sine 30 equal to 4. That is velocity of man with respect to ground by velocity of rain with respect to man. So from this I can write velocity of rain with respect to man is velocity of man with respect to ground by sine 30. That is equal to velocity of man with respect to ground. We have taken it as 4 meter per second. Sine 30 is 1 by 2. So that becomes 2 into 4, 8 meter per second. So the man would feel that the rain is falling at 8 meter per second to the vertical because he is moving at 8 meter per second at 30 degrees to the vertical because he is moving at 4 meter per second. It is not necessary that rain should always fall vertically. Sometimes what is happening is I might have rain falling at certain angle, but because of motion of person, rain might appear to be vertical. So let's change this. We'll replace this by let's say this is velocity of rain with respect to ground. Rain is falling like this. Now we'll just assume that the man is moving in opposite direction. Man moves in this direction. Then what will happen? He will feel that the rain is falling like this. So this is velocity of rain with respect to, I like the velocity of rain with respect to ground. Right? So I hope you can see this part. This is velocity of rain with respect to ground. This is velocity of rain with respect to man. And this is velocity of man with respect to ground. So this is how they're moving. So what does it mean? It means that even when rain is falling at a certain angle, it might appear to be vertical. In this case also the same process remains same. Let's say I assume that the man is moving at 4 meter per second and he feels the rain which was actually falling vertically to be falling at 30 degrees. Again I'll use trigonometry. From trigonometry what do I have? I have tan 30 degrees equal to how much? Velocity of man with respect to ground by velocity of rain with respect to ground. I need velocity of rain with respect to ground, that is velocity of man with respect to ground by tan 30. As we have assumed, if I take velocity of man with respect to ground as 4 meter per second, 4 by tan 30 is 1 by root 3. So velocity of rain with respect to ground is how much? 4 root 3 meter per second vertically. So once you are comfortable with this vector difference, then you can solve all these questions. So rain man situation is one of the common examples that we have. The other common example that we have is river boat problem. When a boat tries to cross a river, let's say it tries to cross it in the least possible time, then what it will do, the river will try to go exactly perpendicular. So the boat will try to go exactly perpendicular to the flow, but the river will take it like this. So if I take this as velocity of boat with respect to river, and this is velocity of river with respect to ground, then as a result of reverse motion, instead of going to point A, the boat will go to point B. So this part is called drift. Now this drift comes due to velocity of the current or the flow of water. Now let's find this is velocity of boat or man with respect to ground. So how do I find it? So this is a situation where the person is trying to cross the river in least time. So if he's trying to cross the river in least time, width of the river is d. What is velocity in this direction? It is velocity of boat with respect to river. So I can say time taken equal to distance by velocity in that particular direction. So this is VBR. Now once I know what is time, I can find out drift. So what is drift? Drift is velocity of river with respect to ground into time. Because the time the boat crosses the river will take the boat down the stream. So this is what is drift. So once we know this, if you want to find what is velocity of boat with respect to ground, you can do it, because as we know, velocity of boat with respect to ground would be velocity of boat with respect to river plus velocity of river with respect to ground. In this way, I can find out what is velocity of boat with respect to ground. Again, once you have got this triangle, it's pretty simple. If you know what is this angle, or if you have calculated time, everything else becomes very simple. So this is a situation where the boat is crossing the river in minimum time. If the boat wants to cross the river in minimum possible displacement, then what should happen is, I'll just make small changes to this. Let's say this part, this is velocity of river. That means river is flowing in this direction now. And boat, instead of going like this, because the river is taking it this downstream, the boat has to move like this. This is velocity of boat with respect to river. And this is velocity of river with respect to ground. Now let's say it has to move at an angle theta. Now what is theta? From this I can say, from the figure I can say sine theta should be equal to how much? VRG by VBR. So I can find out the angle at which it has to be drawn. So this is what? This is condition for minimum displacement. Now in minimum displacement, what is drift? Drift is 0. So if drift is 0, then the components of boat's velocity, this will be velocity of component of boat's velocity in this direction. This would be how much? VBR sine theta. And this is component of boat's velocity with respect to river perpendicular to the flow, VBR cos theta. So as drift is 0, what is drift? Drift is velocity parallel to the river into time. So what is the net velocity of boat parallel to the river? I can write it as VBR sine theta. This is trying to take the river upstream, boat upstream, minus VRG, velocity of river current, which is trying to take it downstream, into time taken equal to 0. So from this, what I can do, I can find out VBR sine theta should be equal to how much? VRG. So I can find out what is the velocity of, so in this way, the same thing, I can find out the angle, and this is the condition that has to be satisfied so that the drift is 0. Now I want to find what is the time taken by the boat to cross the river. Now time taken equal to displacement by velocity in that particular direction. So displacement d is the width of the river, by velocity perpendicular to the flow is VBR cos theta. In this way I can find out what is the time taken. So this is how we can find out the time taken or the angle at which it has to be rowed so that it goes, it covers minimum displacement, or it exactly reaches a point which is opposite to the initial point. Now one thing you have to be careful is, let's say we are getting angle theta, they ask you what is the angle with respect to the flow, then you have to add 90 degrees. For example, you are getting theta equal to 30 degrees, that's correct, but the question asked is what is angle between the direction of flow and the direction of boat, then alpha would be equal to 90 plus theta, that is equal to 120 degrees. So be careful while reading the question. Depending on what is asked, mark that answer as correct answer. Hope you could follow this. Thank you very much.